All right, so 2.3, the product rule for derivatives. So if we have h of x function, which is f of x times g of x, so it's multiplications of two functions, then that's how we take the derivative. So derivative of h function is derivative of f times g plus derivative of g times f. So if you call f of x as a function 1 and g of x as function 2, so basically you are taking the derivative of first function times the second function plus derivative of second function times the first function. Okay. With the Leibniz notation, that is how we show it. Okay, so we have d uv by dx. So u is one function and v is another function, and this is u times v. So that's how you take the derivative. So it is the same thing, just different notation. Okay, so du by dx times v plus dv by dx times u. So you take the derivative of u relative to x times v function plus you take the derivative of v relative to x times u function. Let's look at some examples here. So we are given 3x squared plus 2x times 5x minus 1, and we are going to take the derivative. So dy by dx is, remember, so that is the derivative, right? So we can sometimes call it f prime, sometimes call it y prime. So they all mean the same thing. So let's do the derivative. Okay. So derivative, so this is your f function, that is your g function. So I'm just gonna write it in a simplified way without using the x. So f prime, so derivative of the first, times g plus g prime times f. So derivative of the first function, we have 3x squared plus 2x. So we learned how to take the derivative of polynomial functions, right? So if you have 3 times x squared, so you keep the constant, then you have x squared, you take the derivative of x squared, you drop the exponent to the front, you keep the base, you decrease the exponent by 1. So that gives you 6x. Take the derivative of 2x. So again, if you apply the same rule here, right, you keep the constant. So you take the exponent, drop it to the front, which is 1. X, decrease the exponent by 1. 1 minus 1 gives you 0. And this is equal to 2. So 6x plus 2, that is f prime. We took the f prime now. Now we're going to multiply this by g function, which is 5x minus 1, plus, now g prime, so we're going to take the derivative of 5x minus 1, which is, if you do the shortcut, 5, and times f function, 3x squared plus 2x. Okay, so after you do this, if there's anything that you can factor before you expand, do that. But in this case, these ones don't have power. So actually, when you look at these two terms, there is nothing to be factored out at the moment. So we're just going to expand the whole thing and simplify. So 6x times 5x, 30x squared, 6x times minus 1, minus 6x, 2 times 5x, times x, 2 times negative 1, negative 2. So let's expand this one. 5 times 3x squared, 15x squared, 5 times 2x, 10x. So we end up with 45x squared, 4 10 plus 14x minus 2. Okay, so let's look at the second example. Determine the points on the graph of f of x equals 3x minus 2x squared where the tangent or tangents parallel to x-axis. So if the tangents are parallel to x-axis, so this is the x-axis, right? So if you have tangents parallel to x-axis, the slopes of those lines are going to be 0. So that's important to remember, right? Slope is 0 in that case. So in this case, so we are going to take the derivative again. So that is, as you remember, that is the formula for tangents, or so slopes of all the tangents. Okay. So, but this time, as you see, there is a square here out of the bracket. So for now, with 2.5, we are going to look at the derivatives of more complex expressions. In this case, for now, you don't know how to take the derivative using this square here, okay, using the power rule. So therefore, I'm going to write this f of x multiplication of 3x minus 2x squared and 3x minus 2x squared. Okay, and I'm going to use the product rule. So again, this time, this is your, let me do it with 2 colors, okay. So this is your f. So since this is f, you can call it anything else. So I'm going to call this, let's say, g function and h function. Okay. So when we take the derivative, so this time, let me do the g with blue. So we are going to do derivative of the first function, g prime, times the second function, plus derivative of the second function times the g function, the first function. Okay, so g prime. So we are taking the derivative of first function. So 3x, derivative of 3x is 3. Derivative of minus 2x squared. So again, you kind of, the shortcut would be multiplying the exponent by the coefficient in front of it. Negative 2 times 2 gives you negative 4. And decrease the exponent of x squared, that gives you x. So that is the derivative of g. So multiply this by h function, 3x minus 2x squared plus, now derivative of h function. So h is same as g, so derivative of it is going to be again 3 minus 4x. Now times the g function, 3x minus 2x squared. So now as you see, this is factorable, right? So we see 3 minus 4x in the first term, 3 minus 4x in the second, and 3x minus 2x squared in the first and the second term. So 3 minus 4x is a common factor. Also, 3x minus 2x squared is a common factor. So if we open a bracket, so you take the first term divided by this, and second term divided by this common factor, you get 1 plus 1, basically 2. Okay, so 2 times 3 minus 4x, 3x minus 2x squared is the derivative. But as you see, x is also a factor here, okay? So we can take the x out as well. That will give you 2x, 3 minus 4x, 3 minus 2x. So this, again, derivative function is for the slopes of all the tangents. And we want tangents that are parallel to x-axis. So means we want tangents that have slope of 0. So therefore, we will substitute 0 for the derivative. and solve for x. So everything is in factored form, so we can quickly find the x values. So this will give you 0. That will give you 3 equals 4x, x equals 3 over 4. And this will give you 3 equals 2x, 3x equals 3 over 2. Okay, so we got the x coordinates of the points where the tangents are parallel to x-axis. So we can also find the y coordinates. Okay, so take 0, sub in the original function, so you get 0. So take 3 over 4, sub in the function. Let's do it here. Okay, so 3 times 3 over 4 minus 2 times 3 over 4 squared. So 9 over 4 minus 2 times 9 over 16 squared. So that gives you 9 over 8. Okay, so 18, 9. So 9 over 8 squared. So that gives you 81 over 64. Y coordinate of this point is 81 over 64. And we also need the y coordinate of this point. Okay, so x is 3 over 2. So we are going to sub it in again in the f function. So 3 times 3 over 2 minus 2 times 3 over 2 squared. So 9 over 2 minus 2 times 9 over 4. So 9 over 2 minus 9 over 2 squared, which is 0. So that is also 0. We got all the points where the tangents are parallel to the x-axis. So I'm just gonna demonstrate it on a graph. Okay, so we have this function f of x. If you factor x from here, okay, so you have x times 3 minus 2x squared. If you distribute that exponent, you get x squared 3 minus 2x squared. So you have two x-intercepts, one at 0, the other one at 3 over 2. So both of them are double roots, and this is a function with exponent 4 at the end, right? Degree is 4 with a positive leading coefficient. It will start from quad 2 and end in quad 1. So that's how it is going to look like. And we got that at 0, 0, the tangent has a slope of 0. At 3 over 2, again, tangent has a slope of 0. And 3 over 4. Again, those horizontal slopes or 0 slopes for tangents are happening at local max and local min points. Okay? Sure. So this is 3 over 4. So I just took 3 over 4 and 3 over 2, sub in this function, and calculate the y coordinates of the points. All right. All right. So let's look at the next example. You can take a picture of the screen if you couldn't finish writing. Okay. So we have also extended product rule. So if you don't have only two functions, but this time three functions that are multiplied, then we use this extended product rule. Okay. So if you look at this one, so P of X is f of X times G of X times H of X. Then when you take the derivative using the product rule, so derivative of f times g and h plus derivative of g times f and h plus derivative of h times f and g. So basically, so you have a function 1, 2, 3. So you take the derivative of first function, multiply it with other two, plus you take the derivative of the second function and multiply it with the other two, plus you take the derivative of the third function and multiply it with the other two functions. So this rule can be expanded and can be used for any number of, multiplication of functions using the same pattern. So we have an example here. Okay, so find the value of f prime of -1 if f of x is x cubed times 2x squared minus 5 times x cubed minus 2. So we have three functions. So you can consider this one as f, this one as g, this one as h. Okay, so let's then take the derivative. Okay, the derivative of the first function. So derivative of x cubed is 3x squared times second and third function. 2x squared minus 5, x cubed minus 2. Plus, now we take the derivative of the second function. That gives you 4x. So derivative of 5 is 0. So we have only 4x. So now we are going to multiply it with first and third function. So x cubed minus 2 plus derivative of the third function. The derivative of x cubed minus 2. The derivative of x cubed is 3x squared. Derivative of -2 is 0. Now multiply this by first and second function. So x cubed 2x squared minus 5. Let's simplify it a little bit. Okay, so we have 3x squared, 2x squared minus 5, x cubed minus 2 here. So we can multiply these two. 4x to the power of 4, x cubed minus 2 plus 3. X squared times x to the power of 3 gives you x to the power of 5. You add the exponents to x squared minus 5. If the question was asking simplify, then we would expand everything and simplify. But it is not even asking, this question is not asking for the derivative function itself, but it wants you to calculate the derivative at a given certain point, which is -1. So, and if you have more than two functions, it may get really complicated here. If the question is asking direct the value of the derivative at certain point, you can directly sub in, even though it looks kind of messy here, right? But if you try to expand it, it's going to take a lot of time, as you see. So we substitute now -1 in the derivative function. So 3 times -1 squared is 1 2 times negative 1 square. Negative 1 square is 1, so it gives you 2. Negative 1 cube is negative 1. Negative 1 to the power of 4 is positive 1. Negative 1 cube is negative 1. Negative 1 to the power of 5 is negative 1. Negative 1 square is 1. 1 times 2 is 2 minus 5. Okay, so let's see what we have here. 3, negative 3, negative 3, plus 4, negative 3, and 3 times negative 1 is negative 3, and negative 3, so 27 minus 12 plus 9. So 15 plus 9 gives you 24. Let's look at the last example. Example 4. The gas tank of a parked pickup truck develops a leak. The amount V in liters of gas remaining in the tank after T hours can be modeled by the function V of T equals 90 times 1 minus T over 18 square, where time is between 0 and 18. And again, AT is in hours, so between 0 hour and 18 hours. Part A. How much gas was in the tank when the leak developed? So when the leak developed, time is 0, right? That's where the function starts at time 0. So we can just sub 0 in the V function to see how many liters of gas was at the tank. So 90, 1 minus 0 over 18, 0. So you have 1 square, 1, so 90, right? So 90 liters. So this part has nothing to do with calculus at all. So B, how fast is the gas leaking from the tank at T equals 12 hours? So when it is asking how fast, then we need a derivative function. So that is the rate of change, instantaneous rate of change. They're asking at time is 12 hours. Okay, so let's take the derivative. So again, you don't know the power rule yet. So therefore, I will write V of T as multiplications of 1 minus T over 18 times 1 minus T over 18. Okay, so we need again the derivative function. Okay, so don't think that this as multiplications of 3 functions, because 90 is just a constant. Okay, it doesn't have a variable. So you can keep it in front when you are taking the derivative, and open a big bracket and then use product rule for these 2 parts. Okay, so now we are going to take the derivative of 1 minus T over 18. Derivative of 1 is 0. Now what is the derivative of negative T over 18? Okay, so you can think this as negative 1 over 18 T. So then you will be able to see it better what for the derivative. So as you see, derivative of this is negative 1 over 18. Okay, So derivative of first function is negative 1 over 18 times the second function, 1 minus t over 18, plus derivative of the second function. So again, think t over 18, same as the first bracket, right? As 1 over 18 t. Then you can see that derivative of 1 is 0. Derivative of negative 1 over 18 t is negative 1 over 18. Times, so that was the derivative of the second function. Now you multiply it with the first function. So 1 minus t over 18. Now we can see, so as you see, we have two terms here, term 1, term 2, and they are both the same. You can, say that it is 2 times of this whole thing, right? 2 times of that. So let's say if this was x and that was x, then you would say x plus x equals 2x, okay? But in this case, you don't have an x, but you have this expression here. So when you collect these two, so you get 2x, so you'll get 2 times negative 1 over 18 times 1 minus t over 18. So 2 times of that, 2 times 1 over 18 gives you 1 over 9. So negative 1 over 9 times 1 minus t over 18. Okay, so if you simplify this, so 90 divided by 9 gives you 10. So negative 10, 1 minus t over 18 is the derivative function. So now we can substitute 12 in the derivative function. Negative 10, 1 minus 12 over 18. So simplify this. 2 over 3. So you get 1 minus 2 over 3 is 1 over 3. So negative 10 times 1 over 3, negative 10 over 3. And this is liters per hour. This is how fast the gas was leaking, okay? Negative represents, because there is less and less gas in the tank, it is getting less. That is the reason you see a negative sign. So let's say if the amount of gas was increasing in the tank, then this derivative would be a positive value. But in this case, it is negative. Again, this represents there is less and less gas in the tank. Okay, so let's look at C. How fast is the gas leaking from the tank when there are 40 liters of gas in the tank? So this time they're not giving you directly the time, right? They don't tell you, oh, find the rate of change when time is 10 hours or, like the previous question, 12 hours. So therefore you need to find the time yourself. So now you need to find the time when there is 40 liters of gas in the tank. Okay, so we're going to use this original equation. We're going to substitute 40 for the amount of gas. So divide both sides by 90. So we get 4 over 9. 1 minus t over 18 square. So take the square root of both sides. Plus and minus 2 over 3. 1 minus t over 18. Let's solve for t. Okay, so you get t over 18. 1 minus 2 over 3. T over 18 1 plus 2 over 3. So this one, T over 18 equals 1 over 3. So you get 6. Then you do the cross multiplication. This one, T over 18 equals 3, 5, 5 over 3. So you get 3T equals 18 times 5. Oops. Divide both sides by 3. 6 times 5, 30. Okay, so you got 2 times here, 6 hours and 30 hours. However, go and check the given domain. Time is in between 0 hour and 18 hours. So 30 hours is not in the given domain, so we cannot use this time. So we can only take time equals 6 hours. So this means after 6 hours, so the start amount was 90 liters. After 6 hours, there are 40 liters left in the tank. So now we want to know how fast was gas leaking at 6 hours. So we're going to substitute 6 in the derivative function. So this is our derivative function here. Negative 10, 1 minus 6 over 18. Negative 10, so that is 1 over 3. 1 minus 1 over 3 gives you 2 over 3. So you end up with negative 20 over 3.
That's half. Why did you substitute 6 into the equation again?
The question was asking how fast is the gas leaking from the tank. It is not asking what.
Oh, okay.
Okay, so the question is asking actually the instantaneous rate of change when there is 40 liters of gas left in the tank. Okay, so with the first step, we found that there is 40 liters of gas left after 6 hours. But now we want to
Okay.
check how fast it is changing when time is 6 hours. After 6 hours. Okay, that
Okay,
is it.
so you.
Okay,
Oh, okay. Okay, that makes sense. Thank you.
you're welcome. Okay, so that is that. The last part. It says how fast is the gas leaking from the tank 1 hour before the tank emptied? Well, first, of course, we need to find when the tank is emptied. Then we can subtract 1 to find 1 hour before the tank emptied. Okay, so tank emptied means no gas left in the tank. The volume of the gas is 0. Okay, so if you solve for this, you get 0 equals 1 minus t over 18 square. Take the square root, 0 equals 1 minus t over 18, right? So you get 1 equals t over 18. So t equals 18 hours. Well, it was kind of saying it here too, right? The time is from 0 hours to 18 hours. And after 18 hours, now there is no gas left in the tank. The tank is emptied after 18 hours. But we want to know how fast is the gas leaking 1 hour before the tank emptied. So we need to subtract now 1 hour from this to get 17 hours. So how fast is the gas leaking after 17 hours? We use again our derivative function here. Negative 10, 1 minus 17 over 18. Negative 10, 1 over 18. So you get negative 10 over 18. Simplify. Negative 5 over 9 liters per hour.